provides me is hopefully good insight into various verticals and horizontal solutions that are needed in the market. And success for my job is essentially coming up with solutions and solving the problems before you as a customer need them. And so one of the areas we're focusing a lot on, as you can tell from other major organizations is issues around big data. So without further ado, here's what we're going to go through today. We're going to talk a little bit about the big data landscape and where the chinks are, where the issues are, compare and contrast existing data warehouses to what you see in the Hadoop portion of a big data landscape. Talk a little bit about the big data architecture, but not a lot, because I think you've probably got that in boatloads today. And we're also going to talk about, from a security perspective, what works in securing big data environments, in particular Hadoop environments, and what doesn't work yet, and what those potential emerging solutions look like. So, a chink in the armor means a weak point, right? So what's interesting is anytime you have major innovation in any technology field, you'll end up creating some type of risk, whether that's security-based risk or financial-based risk. That's normally what occurs. So I think one of the things that's important as you look at the big data landscape is not all of these technologies introduce any type of security risk. So a lot of these technologies were tried, true, tested technologies. You see big names up there, Oracle and SAP, IBM, Cognos. Those are secure components of a big data landscape. You've had those in your data center for a long time. You're used to working with them. You understand where the chinks in those pieces of the armor are for those products, and you've learned to deal with them. I think what's different here is what you see in the Hadoop technology. So Hadoop is, I wouldn't say immature, but young. It is open source by nature, and anyone that's worked with open source long enough understands that security is probably the last thing that an open source developer will think about or consider. They're all about function and feature and ensuring that they can distribute their code source and collaborate on their code source. So to that point, and Hadoop isn't the only open source technology that has some security issues with it in this larger mix, but it's definitely got the lion's share of them. All right, so for this conversation, we're going to focus in particularly on Hadoop. So I'm not going to drill through this eye chart. You guys can pull this presentation down from the website and take a look at it. But this represents a typical data warehouse. It's well structured. Okay, it's tightly managed. Right. It doesn't have a lot of change or shift in its architecture, and when it does, it's well controlled by enterprise controls, by enterprise change control policies, right? It's very, very dictated in how it takes data in, how it maps data, and how it deals with that data, and how you gain access to that data through tools and API interfaces. Very secure, we're very comfortable with that, okay? What's different when we go to this world? Let's start with the data sources. So the data sources here are not the typical controlled data sources. They're highly unstructured. They may or may not be trusted. And that's okay. That's why we are interested in Hadoop, for our ability to consume those data sets, and those data sets that are extremely large. Okay? In many cases, the Hadoop environments that are starting to grow in the enterprise are not growing within the data center. They're not starting there. Okay? They're starting in the development communities. They're starting in rogue shadow IT business organizations. Okay? So they're not part of that typical change control process that your big data environments are. Right? And because of that, there isn't, I haven't met too many developers that go to work every day going, I got to make sure that the playground that I'm standing at is completely secure. That's not the way they think. Okay? The business person that might be sponsoring that Hadoop environment in their shadow IT, they're really focused on function and usage and how I can leverage that. They're not functioning on, again, hey, I'm pulling in data that might be compromised. I'm standing up environments that could easily compromise that information that is company-based that I'm putting in there. So it's a very different mentality. And you as IT professionals, at some point, are going to have to assume responsibility for that kind of homegrown environment that's been stood up. So that's what hopefully we can prepare you for. The other thing that I think is significant here, and it's kind of interesting, what we see across all of the technology suites, time to market seems to be the only thing that you get out of a business person these days. Now, not that they didn't always want that, but I think with the advent of the SaaS provider models and the advent of a lot of free open source technologies, it's becoming more and more something that they're focused on. They want to guarantee that they're going to get to market sooner, and they'll do it at the expense of either security or at the expense of the organization that they're working for in some way, shape, or form. So traditional data warehouse environments, I've looked at a bunch of different studies. So IDC did a good one, and so did Gartner. 6 to 36 months to get a traditional data warehouse up and functional and usable by the business. Hadoop environments, 6 to 36 days. With a credit card and access to the internet, you can get something stood up and ingesting massive amounts of data in, say, Amazon Web Services or a Rackspace environment very, very, very quickly. Okay? So again, that time to market is driving us to do things that maybe we shouldn't be doing from a security perspective. Okay? So let's take a look at what works. And when I say what works, I'm talking about the security aspect of what works. So take a look at, and any that were just in the previous presentation, or probably a couple others, you get a good layout of that Hadoop architecture. You understand there's a number of slave nodes. You understand that there is a master node, and that there is a lot of communication, a lot of replication. Okay? So there's tons of data at risk. Now, in these adopted environments, they are probably not going to be running on a secure SAN environment where you have encryption. So depending on what you adopt and or what your model is for standing up your initial Hadoops, because it may be a combination of compute and storage together on those nodes, as is the way Hadoop has grown up so far, I've got data at rest that I need to protect. Okay? So encryption of those is pretty critical. Now the good part is, even at scale, if I'm at the node level, encryption is something that's inherent in most OSs that you can simply turn on with nominal impact, and if performance is a real issue, then I can use hardware-based encryption on those nodes. Okay? And then as you mature, obviously that data set gets moved over to your SAN environments, and you get encryption inherent there, and the problem goes away. Again, this is what works in the security controls. Host node access. What's kind of interesting is I can have a complete collage of host node OSs and versions that will all work in concert in those larger clusters, right? So essentially those slave nodes are driven at the application level, not OS dependent. So host node access is pretty critical. And this is really something that we all grew up with as IT professionals. I make sure I do things like limit local administrative access, limit power user access, limit any type of root access, right? And I authenticate off a central domain in the environment. That's just good hygiene for any typical IT environment. One of the things that is a little bit of an issue here relative to host node access, if I use central authentication schemes, a central Kerberos scheme, or another LDAP scheme for authentication and access to those nodes, I'm going to have a little bit of an issue, right? Simply because of the volume and size of the number of nodes. So I think in the previous and several other presentations, folks are talking about 600, 700 node clusters, okay? So it's fine when you build that cluster out yourself. It's not fine when you adopt that cluster and then have to go clean up someone else's mess where they didn't use a central authentication scheme. Node and API authentication, again, Kerberos is something that is built into a good number of the distributions that are out in the market today, and it will continue to mature and get stronger. And that's something that you should absolutely try and leverage in your environment, but not all large enterprise environments or even medium or small organizations have a Kerberos infrastructure in place. That means you need to find another solution. They do exist, but you need to find them. Transport encryption. So transport encryption needs to be considered both between any of the nodes that are doing any of your node-based replication, between your master name node and your job tracker nodes, and equally important between your query entities. So any of the number of users that are actually hitting that cluster and pulling that information back. Okay? So we have great answers for transport encryption, both at the software level and at the hardware level, if throughput and volume is a true concern there. So again, all of these issues with current Hadoop distributions, we have solutions for that we are kind of tried and true and tested. Right? We've implemented this technology in the past. We've done it with other technologies that we brought into the enterprise data center. Here's what doesn't work quite as well. So the list on the right, 3 things: logging, event and incident management, and control point management. And I'll glue these together for you so you can see the picture. So logging. All nodes, masters and slaves, have the opportunity to log. Now, as security individuals, logging is king, right? If I don't log, I can't tell what happened, and if I'm trying to do things in real time, as much as I can in today's environment, and I don't log, I'm blind, okay? So in Hadoop distributions, it's an option. Logging is not on by default on any of these nodes. So these nodes generate a system.error, a system.log, and a job4j log, right? So there's 3 log types that get produced. Now they have to be turned on, and they can be in varying levels of detail. They can be very cursory, very high level, or they can be very, very detailed. What normally happens in Hadoop distributions is they get turned off, unless there's a problem. Then I'll go turn them on, try and figure out what's going on with my nodes. From a security perspective, we want those logs turned on. So there's a counterbalance here. Most administrators want those logs off unless there's a problem, because then they have a storage management issue on those nodes. So those logs will fill up very fast depending on the level of granularity that you're logging. Okay? So there's a concern there. From an event and incident management perspective, even if I could get that information, current event and incident management systems are not meant for this volume. They cannot scale. In fact, take your current SIM environments and think about what you do to manage throughput and scalability. You essentially only pick critical pieces that you're pulling from, and even then you're doing it in batch. Because these SIM systems were not meant for, for 1,000 different feeds of information coming in instantaneously. They're just not designed that way. Now, I've had event and incident management software producers in several of my discussions, and they'll argue with me, but at the end of the day, they'll admit that, yeah, I'm not really meant to scale to the level that these distributions are going to produce log files at. Okay. Control point management. So one of the biggest issues with security in general, and even more so now that we have a threat service that is exponentially bigger than any single system we've probably ever dealt with before. The threat service is essentially every one of those nodes is a unique threat service now. Okay, so think of 2 or 3 500 node clusters. That threat service is massive. Okay, so control point management becomes important. And when I say control points, I'm not talking about policy-based control points. I'm talking about technology-based control points. So my intrusion detection systems, my firewall systems, my routers and switch environments, right? Where I'm going to actually do some type of segmentation or filtering of traffic. Okay? Those environments are all manual. Those environments can't adapt as quickly as you need them to when you're expanding or contracting these huge Hadoop clusters. Right? So those are the things where we have issues. So now let's talk a little bit about how we can solve these issues and some of the solutions that EMC is looking to bring to market. So use big data to secure big data. Okay? I'll talk to you about what that means in a second. I'll draw a pretty picture. SIM and SOC integration at scale and control point automation. So I'll walk you through this graphic. To the far left are all of my data inputs from a security analytics perspective. So what I'm saying is I want to be able to collect every node log file in high logging. And oh, by the way, I don't want to do it in batch mode. I want to do it in streaming mode. There's a number of vendors out there that provide streaming agents that can run on every node, and they're multi-vendor, multi-OS, very slick technology. So with that type of product installed in your node, in your cluster environments, you can actually stream those log files to a central repository. So that creates another problem. that means I have to have something that's waiting to receive those files and can ingest that data at very, very high volumes. Well, a Hadoop environment housed and created by IT, with all of the holes we talked about plugged, can actually consume that data incredibly fast. Right? That's one of the powers of Hadoop and other MPP-style architectures. Right? So I now have something where I can actually consume all that information very, very, very quickly, and I can get all that information very, very quickly from my nodes. Okay? You see down bottom a big warehouse circle. And notice the arrow is going this way. It can go both ways. Right? And I'll talk a little bit about that. So I can use, if I choose, traditional batch processing in addition to my streaming to feed my data warehouse environment. And then, again, I keep that information because I want long-term visibility. I want to be able to dig back into that data warehouse 6 months from now and look and see what I can glean from that information from an analytics and security perspective. So I always want to store it. Right? We can also take that real-time feed and have the analytics platform feed that back into the data warehouse in some normalized form. Okay? So there's a two-way flow to actually keep your historical data for auditing and or any type of security forensics that you need to do after the fact. So as I pull that information into the analytics environment, I'm doing something else here. Not only am I pulling that stuff into real time, which is something that security professionals have wanted forever, and the technology has limited them, okay? I can get real-time feeds. When I have real-time feeds, that would imply that I would either know about a problem when it occurred or very, very soon afterwards, and I could react to it very, very quickly and cause that problem to go away. So, interestingly enough, there's a recent IDC study, actually it's a Forrester study, and it said 80% of companies today have been breached and don't know it yet. Simply because breach duration and figuring out that breach takes so long. For all the problems, for all the reasons we just discussed, in a standard environment, say nothing about this huge attack service that we're introducing. So in a standard environment, they get their log files in batch. They have a hard time correlating it all because the engine isn't meant to collect it all that network traffic, all that packet data, all the application log information, all the OS log information, all the switch and router log information, all the firewall log information, and put it all together in a correlated time frame. Okay, it just can't handle it. Right? So if I can do this and pull all that information in and correlate it together, the other thing I need to be able to do is react to it in the same time frame. Okay? So to do that, essentially this environment is wrapped with a series of APIs that are two ways. They can both dictate to external entities and receive commands back from other entities to create a link or a hub execution engine. For instance, I have my information flowing in, I determine that there's a breach in real time, I can see the inappropriate activity because I understand the network pattern that should be occurring. I then want to, in real time, shut down and or segment that portion of a VLAN where I see that inappropriate traffic path. If I have this wrapped in an API and a rule set, I can then dictate to that VLAN environment, close off, shut yourself down, or reroute that traffic and isolate that node information. Okay? I'll take questions in a minute, okay? So there's a couple of key concepts here. A, real-time feeds from your node data. B, an analytic environment where I can actually consume that and create rules and then cause actions to occur in my environment and automating those actions to occur in the environment. Okay? When I do those things in concert, I get something very interesting occurring. Okay? I actually get an environment that reacts to very, very quickly the problems that it's seeing. Now, aspirationally, and you'll see a lot of hype in this in the market, if you look up security dynamics or query security dynamics or security analytics, you'll see a lot of things about predictive analytics. Okay? So, predictive analytics is much like anything, as much, an eye of Newton, wing of bat conversation as you'll hear today. But the analytics and a logarithmic formulas and the security data scientists that are starting to unearth themselves Within the next 4 or 5 years, those entities will actually be able to predict when you're going to have a breach and when you're going to have an attack using this type of technology. One of the key things here, it's the only block I haven't addressed, is this bottom piece. It's tagged live intelligence. So essentially what this is, and this is a growing, there's definitely a groundswell in the industry. Some of it led by RSA, which is an EMC sister company. Essentially what this live intelligence feed is organizations opting to share security-oriented information patterns, breaches that maybe have occurred to them, out to a global set of folks that can choose to consume that data. And when I say share, it's not like, this is what we saw happen. It's literally, here's the traffic pattern, or here's the malware footprint, or here's the virus footprint, or here's the phishing model. And it can be exposed in technical terms. And then you, as someone that might be subscribing to this potential feed, can actually take that data, pull it into your analytics environment, and compare it to your exposure footprint and the known ways people gain access or might breach your environment. So from a predictive perspective, what this should give you is a view that is outside of your normal purview, and the ability to understand what might happen or may be happening across maybe your vertical. Right? So if an initial financial services company is breached and they choose to share that pattern of breach out to that pool of information, other financial services companies could pull that in, right, and map that to their exposure footprint or to their applications that might be shared across that vertical, and actually harden their environment ahead of the breach occurring. Okay, ahead of that wave hitting them as the next FinServ organization that might be taken down. Okay, look at what happened to the New York Times. Okay, that breach is absolutely predictable. All right, and if you had the ability to actually see other large print organizations or online print organizations and see their external traffic, you could probably see some of those same patterns that had occurred right before the New York Times happening on those other websites as well. Maybe not at the same time, right? But eventually through that path, if I'm a hacker and I had a successful breach, right, of a certain financial services organization, or in this case, the New York Times, a newsprint organization, what do you think I'm going to do? I'm going to go find another one in that same vertical and see if I can do it again. Right? So that's what this sharing concept is about. Now, it's not an evolved technology, it's not an evolved environment or an ecosystem, but it is absolutely growing in thought process because of what I just described. Okay? So probably one of the reasons everyone is here is trying to get a better handle on who's playing in this market, who's forward-leaning and thinking about the next problem set, whose technology is the most mature. I'm not here to tell you which one of these organizations has the best toys to play with, but what I will tell you is, and this is historically proven, organizations that tend to develop partnerships to enhance or strengthen or complement their go-to-market with a given piece of technology will tend to come out on top at the end of the day. Right? So collaboration and ensuring that you go to market with, if your product isn't going to offer up that feature function set or provide that solution set, make sure that you're going to market with someone else that can augment very quickly so that you can have the shiniest ball on the playground when you actually do go to market. So this is something done by Datameer, and this is targeted at the Hadoop ecosystem. And it essentially says, these guys in that circle on the left, okay, they've got the strongest partnership ties for complementary technology, and it could be anything. It could be all the way down to hardware level. It could be all the way up to complementary software, right? And so these guys have the strongest partnership relationships as it relates to Hadoop. It's a great way to look at the ecosystem, and it's a great way to do a little bit of crystal ball reading on who's going to be standing at the end of the dogfight. And these are the guys that are going to be there. Now, the big shots, right? Hortonworks, MapR, IBM, Microsoft, EMC, Cloudera, Amazon. Not a big shocker there, right? You probably would have talked to those people and worked with those people anyway,
But this is a little bit of statistical data to kind of back up the direction that you're heading. Okay? All right. I think I'm 10 minutes ahead of schedule. Thank you very much. I appreciate your attention at the end of a long day. Thank you. I appreciate it, guys.
So, Mr. Burgess, my first question, I have two. You
Sure.
mentioned New York Times and traffic analysis of the site. Did you actually read the story about what brought them down?
I did. I'm suspect of the story.
So you believe it was somehow an attack against their actual site, even though we know that the registrar was hacked, was spoofed, and that a number of sites were taken down at the same time, and we can look at the registrar record showing that,
Yeah.
and we can look at the full DNS record of what happened. You don't believe any of that?
I believe some of it. I think there's more to the story. I'm always suspect. It's my security hat on. I can't help it. Even when I read something and I see it in print, I tend to second guess a few things.
Is there any traffic knowledge you have that would indicate it was others?
No, we were not directly involved. Neither was RSA.
Okay.
So this is not a company view.
Okay. So
Just my own paranoia.
The real question was about the VLAN. You mentioned detecting that you have an anomaly,
Yes.
and then somehow determining that that is some kind of an attack. But there's
Yep.
lots of
There are
anomalies.
tons of false positives. So
There you
that's
go.
actually the biggest issue if you take a look at IDC systems today. The false positives outweigh the true negatives by an order of like a 10,000 to 1.
That's
It's
right.
crazy.
But
So
would you shut down the VLAN right at the first anomaly? or-
no. So here's the magic sauce, and here's, like I said, some of this is very forward-leaning, but it's probably not more than 24 months away in all honesty, especially in the market pace we're looking at. So in that scenario, in that description, when you have IDC systems that are authoring tons and tons of false positives, how do you deal with it today? You ignored them all, and when the real one happens, you don't know about it, and the IDC system fails. That's because there's too much manual component work to those false positives and analyzing them. There's too much data for a team of IDC specialists to handle in most reasonably sized enterprises. What you need is some type of a logarithmic entity to actually manage those instances and truly understand via correlation, not via pure instance of a false positive. You have to have a correlative engine that can look at any number of probably 20 or 30 different variables at the same time in the right timeline. We don't have those environments set up today.
But folks have been building these naive Bayesian analysis mechanisms since 1995, and they've gotten better over time.
They have improved. They have improved.
And they've been deployed. There's no Fortune 500 firm I'm aware of that doesn't have one of those.
They have improved, but they still don't correlate all the data they could.
Because they don't have the Hadoop implementation? Or?
Well, take the product name out of it, right?
Okay.
Because they don't have the ability to ingest both all of the internal potential mechanisms that would target the correct issue occurring or anomaly occurring. And they're not pulling from external entities that might be able to share even more insight into what that positive or false positive might potentially look like. So the issue in those Bayesian models is they don't have enough data. Why don't they have enough data? Well, A, it becomes really hard to manage it, and it's wicked expensive to keep all that data, and the analytics engines, in all honesty, the analytics engines, the big MPP engines, above and beyond Hadoop, have just hit kind of not even maybe adolescence, right? They're not even full-grown adults yet. So we've got an interesting thing occurring here. We're getting maturation of good solid technology. We're getting, an infancy of very cheap, large-scale data querying and analytics possibilities. You put those two together with our traditional DW environments, you combine some external data feeds where you're not concerned that you're going to suck in 5 terabytes of information today. That's just run-of-the-mill.
So you mentioned you're looking for partners. So if we produced that solution where we took the Bayesian algorithms and a Hadoop architecture, we could sell it through EMC?
So there's already companies out there that are looking to do that. Not to sell through EMC particularly. There's a term that you hear a lot in EMC conversations. We don't want to be in the war. We just want to provide all the weapons.
All right.
right? So that's the whole EMC thing. We want to be the arms provider, right? And so that's what we're doing for all our service providers. That's what we're doing for all our huge enterprise customers. We provide them all the arms and they can go fight the battles, right? But to your point, there's already organizations out there trying to understand, since I have this confluence of technologies that are actually going to enable me to look at, 1,000x the time of data, the amount of data I've ever looked at before, and not have to wait for a batch to happen 24 hours from now. What can I do with that? Right? I mean, in fact, I just read this Gartner article this morning. They did a query of the Fortune 1000, and it said, what's your plans with big data and Hadoop? And the largest responsive answer, in fact, better than 80%, said, we're going to adopt it, but we don't know why. Because we don't understand how to use it yet to do something interesting. So what I just described to you was, here's why. From a pure security perspective, here's a use case where there is no question we need it, and there is no question that there's tons of opportunity in the market to go do it, because if we can prove what I just showed you, and like I said, we're 24 months, it will happen, right? There isn't anyone out there that will either not implement it internally and own it and manage it, or buy it as a service.
I can have that ready in 30 days, but okay.
All right?
Please have mentioned.
Who's your company?
Who? My company? EMC.
No. You mentioned that there's a company that do that. All the organization.
There's a number of organizations out there that are looking to do analytics work. A lot of them are smaller firms, smaller security-specific firms. A lot of them have a data analytics background, but they've taken and turned themselves towards a security firm. Okay. Thank you very much, folks. Appreciate it.
So what kind of partners are you looking for at EMC?